So here's how levels are created in Jurassic Rally. The main components of the level is the racetrack, and that's what the level designer will have to edit. Everything else will be generated procedurally. Of course, we can always polish it later, but to get a starting point, it's good to have some aids, right? You see that the terrain is not just noise on a plane. It tries to make some assumptions based on the track design. And if I continue creating the circuit, it will try to create some justification for the track layout. I have just to behave a little bit, and it will work a lot. And let's say I want to generate an overpass here and go back to the start. Just close the circuit, and I forgot to just go up to make sense of that. And there you have with the bridge, and everything else is plugged automatically. You see that besides the art assets, it also generates game mechanics assets like the path for the dinosaur. The path for the dinosaurs detect, for instance, sharp curves that it should slow down if they're indicated by the warm colors. The blue color indicates where it should accelerate, like on descent. Well, if the track is in this way, it's a descent here and an ascent here. So here the dinosaurs will also slow down. And I find this approach more interesting than simple nav mesh because, well, I can't find the shortest path, but I also add other information the dinosaur can use to make a more interesting gameplay, right? So everything is generated from very quickly from this user input curve with Houdini assets, right? So racetrack is the basis, and terrain takes as input the racetrack and everything else, right? So how does that work? Here in Houdini are the main components. The main track editor generates the road. We have gameplay and data visualization assets for now. That's the shortest path and the race map that's generated automatically, and puts the thumbnails of the characters there, and also keeps tracks of where everyone is for the gameplay. The path manager takes in account the circuit. It's used by the dinosaurs to follow the path. It also has a path estimation time that when I hit play here, in just a moment, it will estimate the time it takes to complete the whole circuit, considering acceleration and deceleration and everything else, length. It will give me an estimated time for a lap, and I can use that to quickly set the goals for each track. So the dinosaurs use path follower. Both the dinosaur and the car uses a path overseer to monitor where they are in the game. And pterodactyl is a mechanic that will avoid that you cut paths. It will snap kidnap you when you try to cut corners, and everything's plugged like that. So back to Houdini, we have the gameplay and data visualization assets and set dressing and extra collision, the terrain, the scattering of geometry, and so forth. And everything else. So the racetrack. Racetrack is, like I mentioned, is generated by the simple let's just hide everything else here. From a very simple input curve from the user. From that, I generate some information like well, the tangent, directions, the overpass is detected here, and that information will be used for both the art and the gameplay assets, right? To make the shortest path, I use from this curve. Of course, I will follow with the loft and the sweep of the curve, but the interesting part is finding the shortest path, right? So here's how it works. You see that it's important that everything is quite interactive. So I tend to write everything in Vex instead of using Houdini nodes. So you see that it was easy to create. But, well, anyway, here's how the shortest path is calculated. Of course, this is just an illustration. The actual calculation is here. I guess I could use calculus to make a more elegant approach, but this method is quite fast. Actually, it's even faster than, I guess it's one of the, well, it's quite fast. You see that it doesn't slow down level creation, but here's just to illustrate how it works. It tries to find a should raise for the next paths, and it hits a wall, it straightens that curve, right? So with the racetrack, we will output, well, the geometry for the terrain, but also it will output other information with it. And that's why when, for instance, I get to the terrain and add the racetrack as an input, it considers it, I have to set it to a Houdini assets input instead of just geometry, because it will use the curvature to generate the rest of the terrain. Like on curves, it tries to clear side for making, for instance, when we are on a straight, you see that we are walled in, but on a curve, it tries to make a more interesting horizon, right? So that's the algorithm for the terrain. Here, everything is controlled by some parameters. And that's that. Then we have the scattering points. Also consider make some assumptions based on the topography. Doesn't just scatter everywhere, and that's how it makes things a little bit more interesting. And that's how easy it is at the moment. And as I develop further, I can edit these algorithms, create alternative approach to it, or even polish this a little bit more further on. Like, for instance, one thing that I want to make is improve how the transition between track and terrain to make it more natural instead of this sharp seam. And as developments go on, I plan on iterating on these algorithms to improve and the overall look of the game. So when I make an improvement on one asset, all the levels are improved at once. And it's always easy to go back to a new track and edit and make modifications to cater for a better gameplay without worrying about losing artwork, because everything is, well, procedural. Thanks for watching.